Good day everyone and welcome to our presentation. Today, we are excited to share our group project, the Campus Bookstore System. We designed this terminal-based application to help bookstore cashiers process transactions faster, prevent errors and get instant sales data right at the counter. Let's look at how it works. Starting with our project summary, this program is a lightweight console tool built for everyday cashier operations. It features smart input, meaning the cashier can keep adding book prices dynamically up to a maximum limit of 10 books. To keep the system running smoothly without crashing or recording bad numbers, it includes built-in error prevention that completely block negative numbers or text inputs. Once the transaction is done, the system applies smart discount, giving a 10% discount if the total hit 80 ringgit or a 15% discount if it hits 150 ringgit. Finally, it provides instant insight, displaying a clean receipt along with a calculated sales analytic. When we built this system, we focused on three main objectives. The first one is to replace manual tracking by providing an efficient digital platform for cashiering and computing customer purchases in real time. Next is to systematically store multiple item prices in an array structure, enabling the system to automatically calculate the subtotal, average book price, and instantly identify the most expensive and cheapest item. And the last is the system aims to produce a clear visual receipts and analysis summary that display all process, transactional data and bookstore calculation for the user. Now, let's look at the underlying logic using our input, process and output table. Inputs are very simple. The cashier only needs to type in the book price and a Y or N choice to keep going or stop. Now, the processing phase does the heavy lifting. It checks if the price is valid, stores it in our array, and runs our core function to calculate the subtotal, average price, and extreme values. It then evaluates our tired rules, checking if the subtotal qualifies for a 15% or 10% discount, and figures out the final grand total. Finally, the output displays two clean blocks, the purchase summary, which acts as the customer final receipt, and the bookstore analysis, which shows the cashier transaction average and price extremes.
I will explain about the pseudocode for our Campus Bookstore Management System. The program starts by calling the display welcome function to display a welcome message to the user. Then it declares several variables including max books, which is set to 10, an array called book price to store the price of the books, book count to keep track of the number of books entered, choice, and student discount. Next, the program uses a do-while loop to allow the user to enter book price. Before accepting a new book, the program checks whether the maximum limit of 10 books has been reached. If the limit is reached, it displays a message saying maximum book limit reached and stop the input process. Inside the loop, a while loop is used for input validation. The user is asked to enter the price of each book. If the input is invalid or the price is less than or equal to 0, the program displays an error message and asks the user to enter the price again. Once a valid price is entered, it is stored in the book price array and the book count is increased by 1. After that, the program asks the user whether they want to add another book by entering Y or N. This process continues until the user chooses not to add more books or the maximum number of books is reached. If no books are entered, the program displays the message "No book will register existing system" and terminates. Once all the data has been entered, the program calls three functions. The calculate total function calculates the subtotal of all book price. Find highest finds the most expensive book, and find lowest finds the cheapest book. The average book price is also calculated by dividing the subtotal by the total number of books. Next, the program calculates the student discount. If the subtotal is 150 ringgit or more, the customer receives a 50% discount. If the subtotal is 80 ringgit or more but less than 150 ringgit, a 10% discount is given. Otherwise, no discount is applied. Finally, the program displays the purchase summary, which includes the total number of book purchased, the subtotal, the student discount, and the final grand total. It also displays the bookstore analysis, showing the average book price, the most expensive book, and the cheapest book. The program ends by displaying the message, "Thank you, see you next time."
Thank you, Alicia. Now, I will present the flowchart for our Campus Bookstore billing system. The process starts with a welcome message and prompt the user to enter a book price. Before saving it, the system checks if the price is a valid positive number. If someone input an invalid price, the system shows an error message and loop them back to try again. Once a valid price is entered, the system saves it in an array and increase the book count. It then asks the user if they want to add another book. If they type Y, the loop repeats for the next item. But if the user type N, the system stops collecting the prices and process the data. It immediately calculates the subtotal, the average book price, and identify the highest and the lower price. Next, the system automatically determines the discount based on the subtotal. If the subtotal is over Rm 200, the customer will get a 10% discount. Meanwhile, if the subtotal is over Rm 100, they will get a 5% discount. Otherwise, the discount is 0%. And then, final grand total is then calculated by subtracting the discount from the subtotal. Finally, the system displays two outputs, a detailed customer receipt and a quick price analysis. After showing a friendly thank you message, the program ends.
Hello everyone, and good morning to our respected lecturer and classmates. Today, our team will be presenting our project for CSC126, the Campus Bookstore Management System. My name is Ahmad Shaheen, and I'm joined today by my team members, which is Muhammad Fazruddin, Alicia Khuraisha, and Nur Sofia Balkis. As we know, managing a campus bookstore involves handling multiple transactions daily. Doing this manually can lead to human error, such as calculating wrong totals, applying incorrect discount rates, or losing track of transaction patterns like average book cost. To solve this, we developed a C++ console application designed to streamline book purchase, validate pricing inputs, automatically apply tiered student discounts, and generate an immediate analytical report of this transaction. And now I want to explain how the core system logic handles these operations. Let's dive into how the program operates behind the scenes. The application starts by initializing a fixed array size of 10 to limit the maximum books per transaction. We use a do-while loop to handle data entry dynamically, allowing the cashier to stop adding items whenever they want, or automatically stopping when the 10 book limit is reached. Inside this loop, we implement a crucial feature, input validation, by utilizing a while-through loop alongside standard error clearing sin.fail. The system rejects any negative values or invalid text characters, forcing the cashier to enter a valid positive numbers before proceeding. Once data entry is complete, the program calculates the subtotal and automatically evaluates it through a next conditional structure. If the subtotal is 150 ringgit or more, a 15% discount is granted. If it's 80 ringgit or more, a 10% discount is applied. Anything below 80 ringgit receive no discount. To keep our code clean, modular, and easy to maintain, we separate our core math process into independent functions. We pass our book price array into this function alongside the dynamic book count tracking variable, calculates total. This function uses a traditional for loop to iterate through the array elements, dynamically accumulating the price to return a precise subtotal, find highest, and find lowest. This uses an element comparison algorithm. They initialize a benchmark using the first element of the array, items, open bracket, 0, close bracket. Step through the remaining elements and update the benchmark whenever a higher or lower price is encountered. By isolating this process, our main function stays highly readable. Let's see the system in action. When launched, the program displays a formal welcome header. I'm going to input 3 books for the demonstration. Notice that if I accidentally type a negative price or a typo, the system triggers our input validation block and safely prompts me to try again. Now I will add 3 valid books priced at 50 ringgit, 40 ringgit and 70 ringgit. Our total subtotal equals 190 ringgit. I will press N to stop adding books. As you can see, because our subtotal hit 190 ringgit, the system automatically correctly applied the highest tiered 15% discount, which is 24 ringgit, bringing our grand total down to 136 ringgit. Directly beneath the receipt, the bookstore analysis table calculates our matrix seamlessly. It reflects an exact mathematical average of 53.33 ringgit. Correctly pinpoints our most expensive book at 70 ringgit and our cheapest at 40 ringgit. In conclusion, the system achieved our goal of providing an accurate, robust, and user-friendly interface for campus retail management using core structural programming principles like arrays, loops, and modular functions. That's all from me. Thank you.